Hi, this is Kevin. Welcome to my lecture introducing the syllabus and the course and the courseware for IS430, Foundations of Information Processing in the summer of 2021. So what we're looking at here, for the most part, let's expand that a bit, is the Moodle site for our course. Okay. And I organize my Moodle sites for all my courses pretty much the same way. So the first thing that you'll find is a link to the syllabus. Okay. And I don't know how I managed to do that, but if you click on the link to the syllabus and you click again, you'll go to the syllabus. Okay, and this link will always be good. So if there is an update to the syllabus, I'm not anticipating one right now. But I will change the link, and I'll, like any other time I make a change related to the course, I'll post in the announcements forum. So the next thing is the announcements forum. These are available on the website. They are emailed to you as well. So far, I have announced a welcome, that the syllabus was available, that the weekly schedule was then available, and that we had a confirmation of who was going to be our TA for the semester. Okay, so we're all set. Okay, so whenever there's news, like I promised you some content and now I finally posted it, I will post announcements here. All right. Open discussion is another forum. Okay. This is a forum for students to converse with other students. Okay. I will weigh in from time to time if I think I've got a lot of value to add in steering the conversation. Okay. If you want help from me, this is not the place to get it. Okay. I'm not saying it's not the place to go for help. Place to go for help is the service desk for this course, which we'll talk about in a couple of minutes. I'm in it several times a day, but you should feel that whatever you post to me there, if you open a ticket, that either I or the TA will get to it within 24 hours, often sooner. Okay, that's the place to go for help. Now, sometimes students want help faster than that. I wonder if another student has an idea about how to solve this problem. Well, certainly do it here. Okay, but if you also want help from me, in addition to posting here and trying to get some helps or some insight from your classmates, well, open a ticket too. Okay. Zoom interface. So all of these classes and labs that we're doing are going to be on Zoom. Here's a list of all of them. Okay. Well, all of them that are on page 1. Okay. There's a link for our first class, Wednesday, May 19th at 6 p.m. Okay. The next is a link to our first online lab, Sunday, May 23rd at 10 a.m. And if you go down here, it goes class, lab, through the end of the semester. This is the right place to come to sign into Zoom and get into the meetings that we're going to have. Because when you sign in from here, it knows who you are. Okay. First of all, it gives you proper authentication to join the class. But the other thing it it does, it connects you to the metadata about you so that we'll see your avatar, we'll have your proper name, all that kind of stuff that leads to quality interactions in class. So please sign in through here. Okay, now we've got a bunch of tabbed information here. We have the first of the tabs is course information. Okay, the basics, the number, the name. It meets on Wednesday evenings. Okay, information about the instructor. That's me, Kevin Trainer. I don't have an office at the iSchool, but I will in hopefully the beginning of the fall semester when we move into the new building. So I'm kind of looking forward to that. But in the meantime, if you want to meet with me, you can either do that in a formal online lab session, okay, or you can do it in the part of the class. At the end of our typical class, I convert over to some online lab time for the rest of the class time. You can do it then. Or if you need an individual meeting, use the service desk, which we're going to find out under the Contact Us tab. Use that in order to contact me, and we'll set up an individual meeting. Okay. Here's information about our TA. Our TA has TA'd this course under another instructor several times. She has a lot of experience. I'm really looking forward to working with her, and I think that you should too. Next tab, your preferred name. Okay. Quite a few of you have probably had the experience that when you go on to Moodle or you go on to Zoom, that your name isn't really the name that you want people to use during classes or meetings and that kind of stuff, okay? The way to fix this, if we're not using your preferred name, is to go into the formal systems of the university and change your preferred name, okay? And we have instructions here about how to do it. You can click through and go to a help article created by our friends at the iSchool help desk, okay? Last semester was the first time that I encouraged students to do this. It was a great experience. Okay, so please do it, and do it soon if the systems are not currently showing the name that you prefer to use, because out of respect, the rest of us would like to refer to you in the way that you'd like to be referred to. Contact Us is about the help desk. The service desk. I am very bad at helping students using regular email. They send emails and they get lost. Okay, so I created a help system, a ticket-oriented system using a product called Jira Service Management. Okay, and I got a lot of information on how to get started and how to learn how to use it right here. I've got a tutorial, I've got slides, I've got links with introductions and help and all that kind of stuff. Please learn how to use this. There are 10 participation points, which is a boatload of participation points, that can be earned by finding your way to the service desk for this course and posting a greetings post, opening a ticket that greets those of you, those of us who are going to help you me and the TA, and you earn 10 points for doing that. My experience is when you have a problem that you need help with, you don't want to go find out how to use the service desk. Okay? Now, it's too late. You're frustrated. Okay? So this is a channel that's not hard to use. Okay? If you put a little time into it in the beginning of the course, when you have plenty of patience. So please do. The weekly schedule is a website that shows you the schedule and all the content for the course. We'll be back here shortly. Okay, we have a tab for submit assignments, and I can see that it's hidden. So let's go unhide it. Okay, so submit assignments is hidden. Let's show it. Okay, and let's turn the editing off and go back. So, submit assignments. These are all the assignments that are due. We have a bunch of coding assignments. Okay, and then we have the final project assignment. Okay. Here's where you go to submit your work. Okay. I copied these, actually somebody copied them for me from the last semester where I taught, and I went through and I changed all the times and dates that they're due, okay, to match the weekly schedule, which we will be to in a minute. The weekly schedule is the authoritative date and time when things are due. If you should find that the date and time in Moodle is different, please open a ticket and I'll fix it. Okay? All right? They're meant to be perfectly the same. Okay? And normally they are. I think I made a mistake with one assignment in the spring, and that created a lot of heartache. So I want to avoid that. Okay? We have one more section, assignment solutions. These are the solutions to all the coding assignments. This section is hidden right now. I'm going to unhide it and then hide all these. And then what I do is I unhide each of the solutions just before we discuss them in the next class. Okay, so you're able to download them and compare them to work that you did, and a part of our discussion in the next class is going to be how your work was different than mine and other people in the class. And is that bad? Is that good? Is that something in between? We're going to discuss it, and we're going to find out. Okay, so that's all for the Moodle site. Let's go to the weekly schedule. Okay. So the weekly schedule is right here, okay, and we've got some title information. It's the summer 2021. It's IS430. It meets on Wednesday evenings, and this is an index page. So these week numbers are links, okay. So if you want to go to the schedule for week 1, well, click on 1, okay. That's how they work. And let's make that type a little bit bigger. Yeah, that's a little too big. You can never get the perfect size, right? So week 1 of the course, we're just getting started. Okay? So what are we going to do? Well, first let's kind of understand the weekly schedule pages and how they work. Each box on the page is either some event or it's a note about the schedule. Okay, so here in week 1 we have a class on Wednesday, May 19th from 6 p.m. to 8 p.m. on Zoom. That's the first event. Then on Sunday we have a lab session, an online lab from 10 to 11 a.m. That's optional. And then pretty typically the deadline for the assignments for that week is on Sunday evening just before midnight. Okay, and this is the weekly assignments deadline. Okay, so the assignments for week 1 are installing the software that we're going to be using in the course. Okay, which is, well, you have to pick a computer. You have to install the Anaconda product, and you have to install Pycharm Professional. Okay, all of the software that you're going to need is free to you for the duration of the course, and in the case of this Pycharm Professional, free to you as long as you're at the university. And then there is a free version, slightly less feature-filled, that is free forever. Okay. So that's week 1. Okay. So let's just kind of walk through. Oh, one big thing that we're going to do is introductions. Okay. Well, let's look at a typical class. We've got the topics, welcome, syllabus review, and review weekly schedule. It turns out we're doing them in a recording in order to give us more time for discussion and introductions and things in our first class. We have introductions. Okay. We have a list of required readings. For week 1, it's the syllabus. We have required recordings. Okay. So there's a tutorial on how to play my videos. Very meta. Okay. It's worth a play. Okay. There's a lot of things that you can do to control the pace at which you play these and to match them to the activity that you're doing. And that's the bulk of what I talk about in that tutorial. This is the recording that you're listening to right now. I can't have a link because I'm just creating it as I speak. And then there's the tutorial again, how to use the service desk for this course. And we've already seen a link for that under the Contact Us tab on the Moodle. Okay. Other resources are typically, in this case, they're the slides that go with the recordings. Okay, and then we have a class discussion, a prep, introduce yourself. It's really helpful to be thinking about what you want to get out of this course. It's also helpful to hear what other people want to get out of this course and how they're going to use it. That might kind of expand your thinking about what's possible for you. Okay. On Sunday morning, we have this optional online lab. Here's what we do. I'm just going to read. Please drop by to ask a question, to discuss solutions to previous assignments, to get help with the current assignment, to discuss the final project, or just to say hello. Often, people will come to this online lab, even if they don't have a question in mind themselves, they just want to see what other people are doing. Is there something that they're missing? Right. Does everybody come every week? No. There's a few people who come every week. And then there's a collection of other people who come in and out during the semester. Okay. The idea here is this. Your coding assignment is due on Sunday night, okay? By Sunday morning, you had better get serious about getting this done, okay? So here's what I recommend. If you haven't started the homework assignment by Saturday, well, start it on Saturday, Okay. And if you get stuck, then you can come to the online lab on Sunday morning, get unstuck, and still meet the deadline for Sunday night. Okay. I want to talk about the Sunday night deadline, but this is all installation stuff, so I'll talk about it in week 2. So I'm just going to walk you through the weeks and talk about what we're doing here. So week 1 was just getting to know each other and getting the tools installed and getting started. Okay. Week 2 is the beginning of the real content for the course. So we cover the first 2 chapters from the Zell book. There are 2 books that we use, Zell and Severance. Zell is the main text. Severance is a text that we use for 2 things. There are 2 units that we do out of the Severance text instead of the Zell text. And then I list optional readings in the other text each week. Okay, so for people who are new to programming, or people who do one of the readings and they're just not getting it and they want another source, well, look at the optional readings in the other text. I think they could help a lot. Okay. So we're going to cover chapters 1 and 2. Chapter 1, Computers and Programs, is pretty general. Chapter 2, Writing Simple Programs, is just that, writing simple programs. There are recorded lectures for each of the 2 chapters. Okay. And then we've got other resources here. Okay. We have a lab on Sunday morning. Okay. Because we're covering 2 chapters on Sunday night, there's 2 coding assignments due. Okay. Coding assignments are due at the end of the day on Sunday, 11:55 p.m. Okay. Here's why. All right. I think it's very important for you to do your work and engage with it before you see the solutions. You're going to see the solutions at the start of our class the next time we meet. And we meet on Wednesday. Okay? Now, why do I make the deadline on Sunday night instead of Wednesday? Because when I made it on Wednesday, people had a hard time getting it done. Okay? So I have the deadline on Sunday night. If you have a reason that you need an extension, well, then we have some room for extensions. How do you get an extension? Well, open a ticket on the service desk, and if you make a reasonable case for getting an extension, I'll grant you an extension. Okay? But what we really want to do is we want to make sure that we have this done, that you've fully engaged with the content before we start to discuss the solutions. Because in this kind of work, when you see a solution, it's, well, if you've been paying attention, it looks kind of obvious. It's like, oh yeah, that's how you do it. All right. Well, that's not the situation you're going to be in on the job. On the job, you're going to see a problem and you have to formulate the solution, and that's hard. Okay? It's hard doing all that. When you see the answer, it's like, oh yeah, that's an obvious answer. But that doesn't give you practice at the process. Okay? So that's why we've set things up the way we have. So in this week 2, we're covering chapters 1 and 2, pretty introductory chapters. In week 3, we're covering chapter 3, which is computing with numbers. Okay, so we learn about the kinds of number values that we use in Python, specifically integers and floating point values, ints and floats. And we're learning about the arithmetic that we do with them and all the considerations there. But before we cover the new material, the first thing that we're going to do is we're going to review the solutions to the homework that you just handed in for the prior week. Okay? And the idea there is, one, I'm going to publish my version of the solutions, which are fairly authoritative, but they're not perfect. Okay? And then two, I'm going to have you break up into groups and discuss how all of our things are different and whether you think that's good or bad, or whether you've got questions about that. And then when we debrief that exercise, we have a lot of discussion. So by the time we get to the end of reviewing the solutions and all the discussion, you shouldn't have any questions left about the chapters that we're leaving behind. Okay? If you do, well, there's more time for questions. All right? We're going to cover the new material, which is Zell Chapter 3. Because I've recorded the lecture, I'm just going to give you highlights for the chapter, okay? And here's a chance for you to ask the questions that when you're on your mind from when you read the chapter. Or perhaps you've already gotten onto the exercises, and that's raised some questions as well. So we're going to talk through the new material, okay? That's, I guess, the second part of the course where we deal of the class where we deal with the new material. And then the third thing that we do is, if there's time left, I convert it into online lab time. Okay. Now, how much time might that be? Well, after we pass week one, okay, where the class goes from 6 to 8, there'll be a couple of weeks where we go all the way to 8. That might be a week where we're covering 2 or 3 chapters, and so we have a lot of solutions to review. Okay, but there'll be weeks when we're done at 7:15. Okay, and then we'll turn it into lab. So it's going to take as long as it takes, and I'm not going to keep you there just to keep you there. There's plenty of work for you to do, and I'm going to convert the remainder of the time into online lab. Okay, so the new material in week 3 is this Zell Chapter 3, Computing with Numbers. In week 4, we're going to cover Zell Chapter 5, Strings, Lists, and Files. This is a mega chapter, okay? Now, I really like the textbook that we're using. I really like the Zell book. He does a lot of things that I think are good. You'll see me complain about some of the things that he does because, well, that's the way I am, I guess. But the really cool things he's done here is that it turns out that strings and lists and files are all sequences. They have this in common, and they have a lot of common constructs and concepts. And learning them all together and seeing how they're like each other is really insightful and really helpful. But it makes for a really long chapter. Okay, so in this week, we're doing just one chapter, and certain weeks in the past we've done 2 or 3. Okay, but this is a big chapter, and it's going to keep you real busy. Okay. The next week we move on to Zell Chapter 6, which is about functions, and functions are kind of holders for your Python code. So if you were writing just plain English prose, holders for your prose, holders for your text would be things like paragraphs and chapters and sections. Well, functions are kind of bags for code, and they do a lot of other cool things for us too. And that's what it's all about in chapter 6. The next week, we're in week 6, and we're dealing with chapter 7, decision structures. And this is the first time that we learn about logic that could go differently depending upon some test or decision. Sort of if-else kind of logic, but there are more constructs that are decision-oriented than just if and else. Okay, so we learn how to do this here. The things that we've been doing previous to this are all pretty deterministic. We're doing the same thing for like every piece of data that we get. Starting when we get to chapter 7, we're going to get some data and then we're going to examine it. And depending upon its characteristics, well, we're going to do one thing or the other. Okay, so that's what we cover in chapter 7. Week 7, loop structures and Booleans. Okay, so looping is a control construct in many programming languages, and of course it's a big part of the Python programming language. And it's impossible for us to get to it's impossible for us to get all the way to chapter 8 and not having done anything with loops. Loops are so basically a part of what we do. So I think we're kind of giving you little previews about loops as early as chapter 1 and 2. Okay, but we don't really get into the guts of what loops are and how they work and what the details are and how to use them in a really thoughtful way until we get to chapter 8. Okay, so we'll have seen loops before chapter 8, but we're really going to dive in. We get to chapter 8, and we're also going to deal with another kind of value type that we call Booleans. These are values that are either true or false. Okay, and this allows us to do a lot of logic that's pretty powerful. Okay, and it just turns out to be pretty helpful to learn about that at the same time that you're learning about loop structures. Okay. Next, week 8. Okay, so week 8 we're going to be doing Zell chapter 11. We're going to be dealing with data collections. Okay, and data collections include lists, which are lists. In other programming languages, they're called arrays. Okay, we've already talked about lists in chapter 5. Okay, but now we learned some more about them in chapter 11. Some of the more advanced features. And then we're going to learn about another data structure called a dictionary. And a dictionary is kind of what it sounds like. It's a lookup engine. Okay, and so we feed it these key value pairs. Okay, so we have a key. Let's say we're counting words. Okay, and so the key could be the word cat, C-A-T. Okay, and then every time we encounter the word cat in the input, we would change the value. Okay, so we would begin with 1 the first time we encountered it, and then the next time we'd change the 1 to a 2, and the next time to a 3, and we would keep counting it up. So dictionaries are really good for things like word counting and that kind of thing. So you could count all the words that were in a document, and it would store our counts in these key value pairs. Okay, so the key would be the word text, and then the value would be some integer that had our current count for that word. And it turns out that's a really powerful structure for a lot of things, including word counting, which is the first example that I think we use. Okay, so those are data collections. Again, the lists that we first saw in chapter 5 and now the dictionaries. And let's see where we go next. So in week 9, we're going to do with regular expressions. We do that out of the Severance book because there isn't a chapter on this in the Zell book. Regular expressions are a technology for matching strings, okay? And they're actually a little programming language in themselves, okay? So we come up with these patterns that we use, and we pass the pattern, and then the text we're trying to find instances of that pattern in. We pass them to this thing called a regular expression engine, and it either gives us back, there's a couple of modes. Mode 1 is it tells you true or false. Was it found? Did you find that pattern in that text? True or false? Okay. And then there's another mode where you can not only find things that find out whether you match, but you can actually retrieve a list of things that you matched. Okay, and this turns out to be really powerful for a lot of things that information professionals do. A typical example would be something like, somebody gives you a log file from your web server, okay, and you're trying to count up kind of all the times that somebody accessed the website for your organization in a particular way. They went to a particular page, or they searched for a particular thing, or every time they logged in, or how many people logged in, or all those things. Well, that's all. It's all hidden in a gigantic server log. Okay, regular expressions would be one use case for them. Would be processing that log and identifying or counting and or listing out all of the things of interest that you found. So something that you could do you could do kind of by hand that would take you several days. You could write a program that could do that in a second. Pretty darn fast. Okay, so this is a great chapter, and this is a great capability. This regular expressions capability is built into many programming languages and other tools. So this is going to have a lot of potential applicability to your information professional life. Okay, week 10. Week 10, we're going to cover chapter 9 of the Zell book. It says it's on simulation and design. The simulation part is that we finally learn about the probability aspect of Python. Like, how do you generate random values? Okay, and that's something that you might want to do if you're trying to simulate something. The kind of things that we do in the chapter is we simulate a racquetball game, and then I have you simulate a coin toss game, and then I have you simulate a simple dice game. Okay, but the chapter's really about how to design and write bigger programs. Up until before chapter 9, our programs are not particularly big. They're kind of learning examples. Okay. Uh, One thing that people usually do when they're trying to teach you how to design a bigger program and how to construct it and all that kind of stuff is they pick something that's kind of fun, and the kind of games that we're working with in chapter 9 um, are kind of a great first bigger program to write. Okay, so that's what we're doing in chapter 9. And then in week 11, we're covering the last of the chapters here. It's from the Severance book, chapter 14. It's on object-oriented programming. There is a chapter on that in the Zell book, but it's not as good. Okay, so that's why we use the Severance book. And what we're going to learn here is how to create a custom Python data holder class. We'll have used this back when we covered Zell chapter 11 a couple of weeks earlier. We'll have used a data holder class that I created and I give you. And in week 11, you're going to learn how to design and implement one yourself. Okay? And that's the end of the content. The next week, at chapter 12, is the final project. So, what's the final project? In the last week, we're not going to be covering any new material. Okay? Our final class on Wednesday, August the 4th, is just going to be an online lab. Okay? The final project is due on Friday, August the 6th at the end of the day. Okay? And here for the final project, I've got the instructions, starter files, a cheat sheet. There's a tutorial video here that explains the final project. Final project is an individual project, not a group one. Okay? And it's a series of programs, a series of 4 programs that you have to write that do kind of a data analysis of some data that I give you. Okay, these are 4 interrelated programs in a way that we haven't done interrelated programs before, and the idea here is to give you experience with a kind of a small project-oriented thing, kind of like something that you might do on the job, and get your confidence up that you could do this kind of work, so that if some opportunities should come up on the job, and people said something like, well, I think we ought to do this with paper and spreadsheets. You might say something like, that's the kind of thing that I could do with Python. I could put together 3 or 4 programs, and that would take care of it. Why don't I do that? And you'd have the confidence to do it. All right? That's what we're looking for from the assignment. So there's a lot of information here about the final project. I invite you to read through the instructions, play the tutorial, which is an overview of the final project and what's going to be done. And then I'm certainly open to questions. You can't do the final project in a week, okay? So I've got some things here. There are 4 exercises on the final project. The last 2 you're going to have to do in the final week, okay? Because they deal with the skills that we learned and did in week 11, okay? The first 2, though, exercises 1 and 2, can be done after we finish week 8. Okay, so you can start to work on the final project in week 9. Okay, and you can finish it in week 12. All right, and we'll be talking about that and pointing out, the calendar implications of that throughout the semester. Okay, so that's the weekly schedule. Okay, that should give you a good idea about the topics and the kind of the rhythm of the course, how it works. All right. The one thing that I said I would talk about that I haven't talked about yet is the syllabus, and that's right here. Let's take a look at that. So I'm going to try not to repeat things I've already said as we go through this. So let's look. We've got the title, the semester, the course number, the instructor, and the TA. We've talked about all that. Here it. Oh, this is the wrong course. Isn't that nice? Well, we're going to fix that. So, how can I fix that? Well, I'm going to go to week 1. Okay, I'm going to go to the syllabus and download the linked file. All right, and now I'm going to double click on it and bring it up, and there's the right course. See? It was all there. So, the title, the semester, the course number, the instructor, the TA, that's all stuff that we've already talked about. The class times Wednesdays from 6 to 8. If we finish early, I'm going to open it up to online lab. Please use a headset. That's how we do things here. Online lab sessions are on Sunday from 10 till 11 a.m. I don't like to do this on Sunday mornings, but there's no better morning to do it. So that's why I do it on Sunday mornings. If you need to arrange a private individual meeting with me, open up a ticket on the service desk and we'll find a time and we'll meet over Zoom. Okay? To contact either me or the TA, use the service desk rather than email. The description of this course, I'm going to leave for you to read, but I really like these kind of 3 objectives here. To gain a broad introduction to computer programming concepts, principles, styles, and techniques through lectures and discussion. Then 2, to develop a working proficiency in programming language through lab sessions and hands-on assignments. And 3, to nurture the ability to detect opportunities to apply programming in new scenarios. Okay? So we want you to be able to think about programming, to be able to do programming, and to be able to find use cases for your programming skills. Okay? And those are all things that we're going to be working on and talking about throughout the course. The topics, I think, is a pretty well a list of the topics that I went through in the weekly schedule. The learning outcome, understanding the role of programming, identifying opportunities to use programming in your professional work. You should be able to design, code, and test procedural programs that make use of object-oriented classes provided by others. Design, code, and test simple object-oriented classes in Python. That's the very last thing that we do. We learn how to create those data holder classes. And the the tool that we're going to be using is this integrated development environment, or IDE, called Pycharm. So you're going to learn how to use that. Will you always be using that on the job? No, there's a wide range of programming environments that people use for Python, but if you can learn to use Pycharm, you can learn to use any of the rest. Two textbooks. They're both required. The Zell book and the Severance book. The Zell book is a paperback. There is an electronic version of it. The Severance book is available widely in free electronic versions. This Charles Severance, who teaches at the iSchool at Michigan, has been very generous in sharing his work. I don't recommend that you purchase a printed copy of the book, but I'm sure he'd be glad if you decided to do that. Technology requirements. We're going to be doing all the work on our own PCs. Okay, I tend to say laptop because I haven't had a desktop computer in a very long time. It could be 20 years. Okay, so I've had laptops. It could be 30 years. It's been a long time since I had a desktop and not a laptop computer. But what kind of computer do you need? You need one that runs a recent version of Windows 10 or Mac OS. Could you use a computer that runs Linux? Yes, you could, but there's not a lot of support for that. And I'm not going to be able to support you a lot because I don't run a Linux client, I run Linux servers. So if you want to use a Linux client, you better be somebody who can do a lot of self-support, and please contact me first and convince me that you can. Okay? The two pieces of software that we're going to be installing, Anaconda is an open data science platform for Python that brings together all the Python software in one coordinated way so that you don't have to deal with that haphazardly. And then we're going to be using this Pycharm IDE, integrated development environment. Okay, I've got links and tutorials. You should be able to do it. Okay. There's a link here to the course schedule. So the course elements, readings, okay? So generally speaking, I expect you to do your readings and then play the lectures and then come to class, okay? Now, this is a graduate level course, okay? It's often the case in graduate level courses, we don't lecture about the same thing that we read. Okay? We either lecture or we read, but we don't do both. And about everything we read and what we lecture on, we discuss. Graduate school, we love to discuss. Okay. So, I have provided these resources such that you can read and listen to the lecture and come to discuss, okay? I want you to sample all the resources that we have here and then figure out the combination of those that's going to be the most appropriate for you, okay? The lecture videos, I find that we do better to use our class time on discussions than on you listening to me just talk. In fact, that's why I recorded this. We have quite a few tutorial videos for this class. Uh, they really come in two flavors. Flavor one is how to install and use a particular product like Anaconda or Pycharm. Okay. Flavor two is for each of the coding assignments that I have a group of tutorials that show you how I solve this kind of problem that I'm asking you to solve. Okay, how do I design the program? How do I code it? How do I test it? The whole bit. Okay. The idea is you can play this and you can follow along if that's what you'd like to do. Okay, before you go off and do the assignment exercise on your own. Okay. Now, so I'm typically not asking you to do things that you haven't seen. Okay. And those are the tutorials. I think they're worth playing. The coding assignments are not from either of the textbooks. The reason why are really two. Reason one, the solutions to the exercises at the back of the chapters in the textbook are published. Now, the good thing about that is you can use them for practice and you can go find the solutions. The solutions are in the download from the textbook, which I have a link for that in the early weeks. Okay. The other problem I have with the exercises from the textbook is they're too math oriented and they're too, well, I don't completely like them. So I created all these from scratch about 3 or 4 years ago, and I like them. Okay, and I hope that you will too. Now, here's the deal on coding assignments. Okay, I think you're going to learn the most if you've already engaged with the coding assignment before you get to the class where we review the solution. Okay. Because this is the kind of work that when you see the solution, it's almost obvious. You go, oh yeah, we learned about that in class last week, and oh yeah, that's right. Now, that's completely different from engaging in the question and having to do it from scratch. Okay. Something, when you see the answer, it looks easy. Doing it is a lot harder. Okay. If it turns out that you do it and it doesn't work out, even with help, it doesn't work out because help's available at the online lab and via the service desk. If it turns out that you still can't get it, well, you'll be in the position to learn out, see the solution, and to be able to talk about it when we get to class. Then even if you got it wrong, you're going to learn. Okay. But if you don't do it, you're not going to learn much at all. Okay. So here's what I've done. I've come up with a grading scheme that rewards you for doing it and handing it in on time. Okay. So there are 10 points that have to do with handing in a properly named submission and the right format and everything zipped up the right way and all that kind of stuff. So that's following directions. There are 75 points that have to do with making a good faith effort on all parts of the assignment. Okay? So if you hand it in on time and you follow the directions and you demonstrate good faith effort on all parts of the assignment, you're sure to get an 85. Okay? That's a pretty good support system there. Okay? If you hand it in late, you can't score more than 84. Okay? Now, what about this part where I give a lot of points to naming files the right way and organizing files the right way? Well, in this course, we mark everything by hand, okay? So you are going to create a Pycharm project with your programs in it, and you're going to name it the right way, and you're going to zip it up and submit it to Moodle. And then we're going to download it, and we're going to run every program. So if you do 4 programs, we're going to run 4 of them, okay? And we're going to look that your programs do the right thing. We're going to look through your code. That takes an immense amount of time, okay? So the things that we ask you to do about naming the file and organizing the file and handing it in the right way, it's only by doing those things that this kind of high quality approach to grading it can be feasible at all. There are a lot of computing courses at our university and others where people type code into grading machines. Okay, that's great in terms of learning the syntax of language. Not so good in terms of learning how to be a programmer. Okay, so we're doing the high-end approach to grading, and this 10 points is your investment in that. Participation. Okay, so the participation grade, let's just go down to the bottom and see. The participation is 10% of the grade. Okay, so that's the difference between an A and a B, or a B and C. So it's a big deal. Okay, so pay attention to the participation things that are pay attention to the participation grading scheme. Okay, so there, I believe, and I think I've seen it proven out over time, that students who participate in a course actively learn more. Okay, students who are a part of a course where other people are more active participants, then we all learn more. Okay, so that's the reason why there are points associated with participation. I've got a bunch of activities that you can do to participate. Okay, they have points. I add up all the points and I calculate a grade at the end of the semester. Okay, so how do you earn points? One is that your first, if you make a greetings post to the ticket system, the service desk, within the first 2 weeks, you'll earn 10 points. It's a massive amount of points. Please do it. Okay. The open discussion forum, okay, which is not where I offer help, but there's a lot of people who share ideas there or who share help. 1 point per post, okay. Speaking contributions in class, when you turn on your mic and you speak, 2 points per 2 points per speaking incident. Okay, using the chat during class, 1 point per chat. Okay, presenting your code during class, 5 points. Being a presenter, a spokesperson from a breakout group during class, 5 points. Okay, so here's what I do. I come to the end of the semester and I've got to, collect the data from all these things, and I add it all up and I grade it on a curve. So there's usually a group of people who are at the very tippy top. They get 100. Okay. People who are at the median score get an 85. People who have fewer than 10 participation points get a 0. Everything, including the participation, is graded on a 0 to 100 scale. Okay, and then when I'm calculating the grades, I'm just calculating weighted averages of 100-point scores. Okay. The final project I already talked about, but I just want to point out a couple of things. One, it's an individual, not a group assignment. Okay. Two, two is even though it's like an exam in a way, you're still entitled to help on the final project in the same way that you're entitled to help throughout the semester. Okay, so you can take problems that you're having with your code from the final project, just like the problems that you're having with your code in the coding assignments, and you can bring them to online lab, or you can post to the service desk, and we'll help you. Okay, and we do. There's one more thing about the final project that I'm going to point out, and that comes next. Some of the graduate students in the class have the option of registering for 2 rather than 4 credits. And this has to do with the history of the curriculum at the iSchool. Okay. I don't think that undergraduates can register for 2 credits. I think they have to register for 4. The difference is if you register for 2 credits, you don't do the final project. Okay. Now, what do I recommend? I recommend that you do everything. Okay. There's a lot of learning that goes on in the final project. It builds a lot of confidence. Okay. So if you can take it for 4, please take it for 4. If you need to take it for 2, well then I understand. Okay. I just want to point out that, and this is particularly important in the summer. Okay. If you change your mind about whether you want to take it, from 4 to 2 or from 2 to 4, don't wait until the very end to change your mind. There's paperwork that has to be done. There's approvals from advisors and from me that have to be done. And I don't really care. Okay. I guess I do care because I recommended that you take it for 4. But I'm not going to be hurt if you decide to shift to 2 or shift from 4 to 2 or from 2 to 4. But don't wait until the final seconds, because there's a deadline to decide. I don't know what it is, but it's not the last day of the course. Okay? So if you are interested in this issue, get on top of it early. In terms of the grade components, for normal 4-credit students, 10% of the grade is the participation score, 45% is the coding assignments, 45% is the final project. So a lot of weight on the final project. For 2-credit students, 10% is participation, 90% is the coding assignments. Okay. Now, I have a list here of how I convert the number grades from the 0 to 100 scale to letter grades. I got this from one of my colleagues when I came to the iSchool 13 years ago. And I think it's pretty similar to what most people use. And it's there for your reference. And the very last thing I want to talk about is this section, iSchool and University Academic Policies. And this is 2 things at the same time. 1, it's boring. And 2, it's very, very important. Now, why is it boring? It's boring because this is standard language that goes into every syllabus at the iSchool. It's what in contracts is often called boilerplate. Okay, it's standard text. Okay, so if you've already seen it and you've already read it and you understand it, well, it's pretty much not a big thing. On the other hand, these are all super important issues. So, academic integrity, very important. Okay, inclusion. Okay, treating everybody with the respect that they deserve and they need to be able to expect, very important. Religious observances, very important to those who are observing. Okay, accessibility, very important to those who have accessibility issues and opportunities. Okay, COVID-19, very important to all of us who are still struggling with how to work our way out of this pandemic. So here's what I would say about all of these. Read them, understand them, okay? I'm your first level of help on these, okay? So if there's something that you don't understand, ask me. If you need some help with any of these things, I may not be the end helper for all these things, but I'm glad to be the first line of help. So contact me. I'll help my best. I'll steer you in the place that will get you all the help that you need. Okay, so that's the syllabus. A couple of more comments that I'd like to make about the course. Okay, one, programming is a lot of fun to me. I mean, I wouldn't be doing it. I wouldn't be teaching this at this point in my career if it wasn't very much a fun thing for me. I think it can be fun for all of us. Okay, and my goal for the summer is to have a lot of fun with you, learning how to do these programming-oriented things. Okay, so I'm expecting us to have a lot of fun. It's going to be challenging. We're moving fast, but not too fast. We're doing this over a full 12-week summer semester. There's a lot of help available. The other point that I want to make is that this is a course with no prereqs. Okay, so we're going to get a wide range of students. Okay, some of you have no exposure to programming at all. None, not a lick of it. Okay, you're in the right place. Okay, some of you, maybe you had a programming course 10 or 20 years ago, or 5, okay? Don't remember a whole lot. Maybe some of you are kind of programmers. Maybe you're Python programmers, but you're self-taught, okay? You all have a reason for being here in terms of learning programming in Python more formally. You're all in the right spot, okay? And the help is here to give each of you the sort of interesting challenge that you're going to need to have a fulfilling and fruitful summer experience. So you're in the right place. I'm glad to have you here. I'm going to say bye until next time. Bye-bye.